Okay, so here's some highlights of the lab. I'm not going to do the whole thing for you, but I'm just going to show you how the thing works. So here's the intro. So we've got two springs, and they both have the same spring constant. And you can hang on different masses, and if you don't get them the right length, they'll just keep bouncing forever. So to stop the spring, you push this little red button up at the top, and that gets it at its equilibrium position. So if I were to start it again, I could get to that same point by just kind of clicking on it a lot of times, and it finally stops. Actually, I think if you, let's try it again. So you can see it's got the little red button up here. If I grab this thing, it turns out if I just click a lot of times, it stops. I guess that's when it actually has stopped oscillating. It stops. But the easiest way is to just push the stop button. Now, as far as using the ruler, here's the ruler, and the 0 is right up here at the top. So what I've been doing is aligning it with the bottom part of the spring just before you have that straight section down. So it's right here. So I'm going to put him in between the two. And so if I were to put this 50-gram mass on here and I let it go, and it's going to oscillate, push the red button. And if I looked at the displacement at that point, it would look about 9. So you just kind of have to eyeball it. So that would be a displacement of 9 centimeters, because you can see the scale down here at the bottom is centimeters. Okay, so that's how you measure displacements, which you need to find the spring constants. Now, what else can I show you? Oh, here's the stopwatch. So the stopwatch, that's start and stop and reset. Start, stop, reset. In the lab, I'm going to ask you to count how long it takes for 20 oscillations. That just gives you if you just tried it one oscillation, it would be hard to get the exact moment it's at the bottom. So you kind of have to you just have to watch it go up and down and try to figure out where it is at the bottom. Now, if I use a heavier mass, like this 250-gram mass, it's going to oscillate much slower, so it's easier to tell where the bottom is. So the bottom is, somewhere down here. That's kind of interesting. If you move your cursor, you can get it so it'll switch to a finger just when it hits the bottom. Go, like that. And then you count 20 oscillations. So you would say, what I did was count, and I'd go 0, 0, and then when I started 0, 1, 2, 3, and then I count to 20. I'd start it when it's, which you couldn't use your cursor down here because you wouldn't have a cursor to start the stopwatch, so you have to do it visually. So I'd kind of do it like this. Go. 1, 2, 3, and then count to 20. Okay. Now you can change, in the lab, you're going to go to the small spring constant, and you're going to go to the large spring constant. So that's how you change the spring constants. You can see how the spring gets bigger physically when you do that. And you can see how it affects the oscillation. The lower spring constant is slower. The higher spring constant is faster. And finally, over here to the right, you can see you have different levels of gravity. So the first one you're going to do on Earth. The second one you're going to do with 0 gravity. And what happens there is that the mass has inertia, but it has no weight. So if I stop this thing, you'll see that the unstretched length is 0, because the weight's 0 when the gravity's 0. When you add gravity to it, you go to Earth, then now it has weight as well as inertia. And if you go to Jupiter, that has a higher gravitation, that has a higher G than Earth. You can see it stretches further down, so there's more weight. You're also going to do Planet X, which will tell you, which you figure out using this oscillation to figure out what the, well, actually you're going to use just the stretch. So you know the mass, you know the displacement, you know the spring constant. You can figure out the acceleration due to gravity. So I think that's pretty much it. You have 3 unknown masses that you'll use as part of the lab as well, and the values of the masses are proportional to the size of these things. So you can see it. The pink one's greater than 50, but less than 100. The blue one is greater than 100, less than 250. And the same for the brown one, except it's bigger. So, you know, they're going to go in that order: pink, blue, brown. So hopefully with that introduction and with the directions, you can do the lab. And what I'm looking for you to do is to send in the finished lab sheet with all the data on it as a Word file. Okay, so if you have any questions, let me know.